NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D.
Hello, everyone. Welcome to the HIT podcast. Today, our guest is Shravan. He's a PhD student at the School of Electrical and Electronic Engineering at NTU. So, Shravan, thank you for being with us and welcome.
Thank you very much for inviting me.
All right. So, perhaps we can get started by asking you to familiarize us and the listeners to your research field in a simplified manner. We'll start there. And later on, maybe we can get into more details about your own personal work. So if you had to describe your research field and simplify it to our listeners, how would you go about doing that?
Sure. So my research work is mainly focused towards wireless communication system for trains, especially the metro trains in the urban cities like Singapore, Hong Kong, and many other cities. So I work towards improving the reliability of radio communication systems in the railway systems. So what I mean by improving reliability of radio communication is the trains use wireless communication system to transfer their location along the train track. Unfortunately, they cannot use GPS because GPS cannot work well in MRT stations, underground environments like tunnels. So they need to rely on some other kind of communication system and technology to know their own location. Train knowing their own location. So the train uses finds out its own location along the train track and transfer the location information to the MRT operator so that they can schedule the upcoming trains, maintain the safety distance among the trains, and improve the traffic on the track so that they can run more trains in a less duration at a better safety.
I see. So this is mainly geared towards toward the automated trains or like human drive.
So the latest technology what trains use is communication based train control systems. So the train use wireless communication to communicate the information like speed, location, and other details to the upcoming trains and the operator, and they maintain the safety distance. So my job is working towards how can a MRT operator can guarantee a good wireless communication between a moving train and the wayside equipment so that the exchange of critical information like location of the train and the speed of the train is passed in between the operator and the train.
So it's kind of like a positioning system for trains?
Yeah,
Like it's involved in this?
exchange of information about the position and the speed.
I see.
So I was working on like why does a signal failure occurs in the train systems. So the signal is something which is carrying the location and the speed details of the train. And if these signals are blocked or fail to reach the operator or the next train, the train give a emergency brake and stops. So my research was mainly towards why there is a signal failure in the MRT environments.
I see.
So is your work, because when you say communications, there are different ways of doing it. You could use the internet, you could use, I don't know, UHF or other systems like that. So is your work more on the algorithm side or on the circuit side? And is it using the internet or some other protocols for communication?
Well, my work is mainly towards the physical layer thing, which speaks more about if there is a signal radiated from a transmitter, how far it can reach, or else if there is a signal being received by the train, is there any other external wireless interference blocking these signals? So these trains they use same Wi-Fi technology what we use in many other industries and home automations and other fields.
Okay.
So the Wi-Fi technology is very cheap, so that the operators use to reduce the maintenance cost. But this advantage is helpful in deploying them, but the interference effect from other Wi-Fi systems, for example, in the MRT stations, Wi-Fi near the train tracks can trouble the train signaling system because both signals they use the same frequency, and when one signal with that frequency is overlapped by some other signal using the same frequency, then they are blocking each other.
I see.
So in your specific thesis or specific work, what is the problem you're trying to solve? How were you approaching it? How did it all start? Perhaps just tell us in general, how did you get here to actually get into this topic as a person?
So when I joined my PhD in NTU in August 2017, my professor just explained me that there is a signal failure problem in MRT environments, especially in Singapore SMRT. So she asked me investigate why there is a signal failure and what we can do as a researcher in wireless communication. So I would say that the research problem is finding out why there is a signal failure and how we can mitigate that. So as I said earlier, the signal failures may occur because there's a poor network coverage along the train tracks in the tunnel areas, in the maybe industrial areas, in the MRT stations. The radio coverage is not reaching every part of the track, because of which the signal failure is occurring in few regions. And there could be one more reason, which is called wireless interference, because these trains they use the same Wi-Fi technology what we are using in our houses and other like shopping malls, hospitals, everywhere. So the train signals are being interfered by external signals. In this case, what happens is the same train signals fail to reach the train because of a lower signal to noise ratio. This is a parameter which is used to decode the information what is present in a signal.
So when give me a sense of what would happen if a signal fails. What are we talking about? Is it something that would cause a crash? I mean, I don't think it has happened here in Singapore, but I suppose there are levels of signal failure, and what is common currently?
Well, in the CBTC technology, which is called communication-based train control technology, according to the standards defined, if there is a signal failure for more than 3 seconds, the train should give a emergency brake.
Automatically.
This is a emergency brake because these trains they have something called automatic train protection system inside them. So losing a train signal means train not knowing its own location and train not knowing the location of upcoming trains on the same track, and train not knowing at what speed it should move ahead. So losing a signal means all these things. So losing the safety critical information. I could say that when there is a signal failure, the train becomes blind on the track. So when the train is blind, so it should take a halt. So you can say emergency brake when a signal failure occurs.
Okay. So I'm just trying to think about the old days before we had these very high level common systems. They must have had some systems. Are those discarded? Are they currently there as a backup? Like, is there like what are some physical ways in which people try to avoid to sort of mitigate signal loss?
Well, that's a very good question. Thank you. Well, the railway industry or railway technology is there for more than 100 years, I could say.
Right.
Well, before the latest communication-based train control technology, there used to be some other technology which is called fixed block location finding. Now, the advanced technology is mainly to know the train location with a greater accuracy along the track. But before this, what they were doing was they were dividing the entire train track into multiple blocks.
Okay.
For example, we have a train track of length 100 kilometers. So this 100-kilometer train track is divided into 100 blocks. each block is of 1 kilometer.
Hmm.
So whenever a train enters a particular block, there are some trackside circuits. They detect the presence of a vehicle on that track.
Hmm.
So this block is known to be occupied. This 1 kilometer block
see.
is considered to be occupied. And this information is somehow passed to the train operators, or else there used to be uh, the similar to traffic light. They are like red, green, yellow lights along the track, so that the next train can see these lights and take a stop. When so this is one block which is 1 kilometer when it is considered to be occupied. But to be on the safer side, the system is designed in a such a way that a block ahead of this occupied block and a block behind this occupied block are considered to be occupied.
I see.
I see.
See, even though the train is just 80 meters long, you're blocking 3 kilometers
Okay.
so that no other train can enter this region. You might have observed this red color, green color, and yellow color traffic light of kind of signs along the tracks.
Right.
Yeah. So essentially, you divide the track into different zones,
Yeah.
and then within each zone, you can detect whether a vehicle is present or not.
Yes.
I see. But so yeah, it's a kind of like a low resolution way of doing the positioning.
True, because just for detecting a vehicle of 80 meters, you are blocking 3 kilometers. If you see Singapore MRT east-west line, which is about 50 kilometers length. So there are more than 33 MRT stations in this 50 kilometer train track. So if you use the same old technology, which is fixed blocking 3 kilometers to detect a train of 80 meters, then you cannot run multiple trains in a shorter duration.
Yeah, I was thinking about that. Yeah,
Yeah.
to limit the capacity of the
Yes.
track.
So the advancement in the technology helped in maintaining a gap of just 60 seconds in between one train and the other train.
What does that translate to something in terms of kilometers, or is it time?
Waiting time maybe at the platform.
Yeah. It's not like a waiting time, but if let's assume, it's close to what you said, waiting time on the platform. So if you miss one train at T time, T plus 60 seconds, you have the next train. So that is the minimum possible time gap between the trains. Of course, you can reduce this time, but you cannot do it at a higher speed. So here the trains can reach up to a maximum speed of 80 kilometers per hour.
They do reach such high
Yeah, they do reach. I went on train. I was standing at the train driver's cabin when I was testing the wireless signals. So I have seen that. Yeah, they do reach 80 kilometer per hour.
Wow.
Okay. In your research, what are some tools that have been useful? Because you say that you started and you had this rather broad question of signal problems, find a solution to it. What are some ways that you try to break that down into meaningful tasks for yourself?
So I would define this as two major tasks. One is knowing why there is poor network coverage, even though you have placed a lot of antennas and access points along the track. And the second is wireless interference. So in my first 2 years, I was working more on the poor wireless coverage along the tracks problem.
So what is pool? Did you already explain what is pool?
It's like a weak signal quality along the train track.
Okay.
So there are few regions where the signal quality is very low, so that the train receiver cannot detect the information. Same like your Wi-Fi signal strength or maybe the cellular signal strength. There are few regions where you cannot detect your Wi-Fi signal well. So after doing some literature review and knowing about what are the regions where there could be weak signal quality issue, I realized that the tunnels, the underground tunnels, are the regions where this problem mainly occurs. So then I did some kind of simulations, wireless simulations, where I used mathematical models of tunnels, which are treated as like wave guiding regions. And then I went into SMRT tunnels did physical electromagnetic wave measurements along the tunnels. Well, it is very interesting because we get permission to enter the tunnels only after the train services are stopped. In Singapore, the train services are stopped after 12:30 a.m. And we can enter after 1 a.m., getting the clearance from the operators. So we did measurements along the straight tunnels, curved tunnels, and analyzed the details. Then, after doing the analysis and modeling of those results, and comparing them with the simulation results and theoretical results, we realized that the curvature of the tunnels, the region where there is a sharp curvature, degrades the signal quality 3 times more compared to straight regions or any open regions. This is because most of the radio signals are being blocked because of this curvature. And very few radio signals which are getting reflected or diffracted from these curved parts are reaching the other side of the curvature.
So it will create dead spots, basically.
Yes, true. For example, you have a Wi-Fi router which can cover 100 meters, let's assume 100 to 200 meters. But if you are placing it near a curved region, the coverage area is limited to 30 meters or 40 meters. So theoretically, or when you are deploying the setup, you think that, oh, there should be a coverage region all over this because the spacing between each access point is 100 to 200 meters. But the regions like the curvatures, they block the radio signals. So they are like the weak signal quality regions.
I want to step back for a second about you mentioned that the communication band used for the positioning system is the same one that's used for Wi-Fi, right?
Yes.
So this one is a short wavelength, right? Can it propagate for a long distance?
Yes. So in MRT systems, they use 2.4 gigahertz ISM band frequency for their operation. ISM means Industrial Scientific Medical Band, which is a license-free band in most of the countries. So these frequencies, the area of coverage not just depends on the frequency, but it also depends on the amount of power you are radiating and the radiation pattern and the gain of the antennas which you are using. For example, the antennas which we use in our household environments, they have almost zero gain, or I can say like 2 dB gain, maybe 4 dB gain. But the antennas which we use in the MRT systems are of a higher
Much
gain.
powerful.
Yeah.
Okay.
And expensive and much powerful because they cannot deploy a lot of access points like for every 20 meter or 30 meter. So they see that if we place access point for 200 meters of spacing, then it's easier for them to do maintenance in future as well.
So usually, like in a tunnel, for example, you will have multiple access points.
Yes.
Along the track.
Yes, true.
I see.
And Wi-Fi is the only technology that you currently use, or is there another technology on the side?
Well, the major reason why most of the MRT operators use Wi-Fi is because it's license free. That means you need not to pay any license money to the government agencies because the frequency is a very expensive thing these days after a lot of advantages of wireless technologies. So they switch to license-free technology to save money. Saving money, it means like giving less burden to the commuters in paying the transport fee. Well, they can switch to the cellular frequencies as well, like LTE and other 3G, LTE, but you need to pay a lot of money for that. You reserve the frequency, and this money is again a burden to the commuter.
Yeah, it makes sense.
Yeah.
The fares are increased.
For sure, yeah.
I guess then natural question would be if the trains are using Wi-Fi and the commuters are using Wi-Fi, right? And the train is passing through residential areas which are also using Wi-Fi. Does that all interfere with each other? How does that cause any problems?
Yes, they interfere with each other. Definitely, it is a big problem. But they say something interesting about the wireless algorithms is that if the signal of your interest, for example, the train signal is stronger than your interference signal, then you can still get back the information present in those signals. For example, let me give you an example. So if the train signal is of X power and the interference signal is of Y power level, if X is 10 times greater than, or if X is 10 plus Y, which is 10 dB greater than uh, Y, then you can still recollect the information present. So what I'm saying is, if the interference signal is weaker compared to your signal of interest, which could be different in different technologies. Wi-Fi 2 has a 10 dB power level. Wi-Fi 3 is higher. In Wi-Fi 6, it's like 40 dB. Your interested signal should be 40 dB more than your interference signal. Then you can reconstruct the information present in those signals.
Okay.
So interference still can be mitigated if you can make sure that the interested signal quality is far higher than the interference signal.
And from a technical point of view, my understanding is that when you're using a free band, such as the Wi-Fi band, you're limited in terms of how much power you can shoot out. So you guys get special permission, or is it still within what's allowed for free?
No, well, this is true because there are limitations of how much power you can transmit, the radiation effect.
Yeah.
So every country has a different set of rules how much power you can transmit. In Singapore and in most of the countries, it's 23 dBm. Whether you are using the equipment at your home or in industry anywhere, you cannot radiate more than 23 dBm power level.
DPM stands for DP.
Yeah, decibel milli.
Milli, okay.
Yeah. So, yeah, it's 23 dBm. But in this case, what we do is like we use a efficient antenna with a good radiation pattern. So at home, you use more omnidirectional antenna where the radiations are in all directions. But in MRT systems, we are specific towards the radiation should pass as close as to my train track. They need not to spread around. So they just focus towards the train track. So we use the directional antennas and which can focus the radiation in a shorter beam width.
So essentially to make best use of the limited power that you have.
Yes. And expecting the signals to reach a longer distance.
I see.
Okay. So yeah, just to be clear on this one, you said that you made the discovery that the curvature affects the signals, right?
Yes.
And so I guess we can't really rebuild the tunnels that are already there that have curvature. And so what is the solution? Is it deploying more things?
Yeah.
Or what did you find so far?
So yeah, I cannot suggest the MRT operator to rebuild the tunnels with a different radius of curvature because the tunnel's life is more than 20-30 years. So by the time they change the curvature or the structure, the new technology comes in. Well, my suggestion or my recommendation to the operators is when you find out where are those weak spots and change the orientation of the access point locations, the type of antennas you use, the locations where you need to deploy the antennas. For example, if there is a straight tunnel are very good because the area of coverage in a straight tunnel is more than the outdoor areas. The interesting thing what happens in a straight tunnel is the radio signals, they get reflected from the side walls and they are focused towards that straight region. So it's similar to a laser beam or something which is traveling in a fiber optics where all the reflections are passing through the same straight path. They are not going outside this path. Indirectly, like I would say that they are more directed or guided towards the straight tunnel. So the coverage area is higher. But at the same time, if there is a curvature and the coverage area is limited, like the loss of the signals is 3 times more compared to straight and other regions. So if you make use of this information, make use of the details about if there is a radius of curvature like 300 meters, what could be the loss? If there is a radius of curvature, which is a sharpness of the curve is 500 meters, then what could be the loss? And if there is a straight tunnel of 1000 meters, how many access points? So based on this information, if you can deploy the access point in a smart way, you can improve the coverage with a limited access point and make sure there is no weak signal spot.
Mm-hmm. Great. So the other thing we'd like to ask our guests is just some general tools that you use that is not specifically for this problem you're solving, but as a PhD student, some tools that other PhD students might find useful. Some, it could be, about reading papers, or it could be just life in general. What things have you discovered from that angle of doing the PhD itself?
Well, I recommend like all the PhD students at least to know one mathematical tool where you can use your data, do some kind of modeling, plotting the data, looking at the patterns in whatever kind of data you have. For example, MATLAB is one such tool where you can get your measurement data, plot them, and know what are there in your data, what kind of patterns are there. And then you can do some kind of modeling as well. For example, you have a histogram representing your data, and you can match those histograms closer using a Gaussian curve, using a Rayleigh model, Raytian model, Weibull, or many different mathematical models. So to do anything, this kind of analysis, so you should know at least one tool which helps you in doing this data analytics. Nowadays, other than MATLAB, you have Python, you have R language, and you have Veka as well, where you can do some kind of analysis of whatever data you have.
Mm-hmm. Okay,
All
so
right.
that's one. Any more techniques or tips or tools?
Yeah, these days, if you see, there are like lot of graphic user interface coming up to do your data analytics or to learn anything in a simplest way. Not just learning or analyzing whatever results you have, but how do you present them?
Mm-hmm.
If you want to present them to in a conference, so you use a new techniques like making a GIF of the plots what you have,
Mm-hmm.
making an animation of the results what you have to make an audience understand in a simplest way in a least amount of time.
And
Effort, true.
Yeah. All right. So if we are to look at the big picture of communication networks, in your thinking, what are the core objectives or goals that researchers who are involved in this area are focused on, basically, in the long term? What are they trying to achieve? Like, what are the biggest challenges, or you could say problems that they are facing and trying to resolve?
Well, the main motivation in wireless communication research area is transferring as much data as possible in the wireless medium from one part to other part, or from one user to the other user.
Mm.
So 10 years to 15 years before, if you speak 2G, the amount of data you are transferring from one user to other user is in kbs, 20 kb to maybe 40 kb, kilobytes. When the 3G came in, the data rate has been increased, which is more than 200 kbps. When you speak about 4G and you are transferring your data at a higher rate, which is in mbps. But the latest technology which is coming up, more reality within next 2-3 years, which is 5G, fifth generation
5G.
wireless communication.
Mhm.
There you can transfer a data at a rate of 1 gbp, 1 gigabytes per second. This is the minimum threshold, at least 1 gigabytes per second or more than this. So over the years, if you see consistently, the amount of data you are transferring per second is changed from kilobytes per second to gigabytes per second.
Wow.
So there is a higher rate of exchange of data. You're transferring higher data at a shorter time. So what is that which is changing over the years is the operating frequency.
Mhm.
at what frequency you are radiating the electromagnetic waves. Because, for example, in 2G you use 900 kilohertz,
Megahertz.
900 megahertz, where the channel width, the bandwidth of the channel is maybe 10 kilohertz to 50 kilohertz, maybe rough numbers. But when it comes to 3G and 4G, the amount of bandwidth allocated is higher. So in 5G, if you say like you are saying about you are using millimeter waves where the bandwidth is megahertz to gigahertz. So as you are increasing the bandwidth, you can transfer a higher data. But the only condition which limits the transfer is signal to noise ratio. As I said earlier, your signal of interest power should be greater than noise or interference. You can only receive higher data rate if there is no blockage from the external sources as a wireless interference, or your signal strength is stronger. Let me give an example. If you're using Wi-Fi 6 or Wi-Fi 7, which is giving a data rate of 1 Gbps at home, and you are using a metallic plate to block the radio signals at your Wi-Fi router, you can find out that the data rate is very low because your signal quality has been reduced. When the signal quality reduces, even though you are allocated a wider bandwidth, your amount of data rate is limited. This is a mathematical theory, like the relationship between the bandwidth signal to noise ratio, which is given by Shannon. It's I think it's more than 30-40 years before he said this.
Yeah, I think it's 1940s or 50s.
1940s or 50s.
A long while back.
Long way
But
back.
we can check that, right?
Yeah.
Shannon.
Yeah. So he said this. He gave this equation, the relationship between the channel capacity, which is nothing but how much data you can transfer when a given bandwidth, and at a particular signal to noise ratio. So that formula is still in use to calculate the maximum capacity or maximum data rate. But what we are working on improving is the frequency at which we can radiate an electromagnetic wave. 900 megahertz, 1800 megahertz, 2.4, 2.6 gigahertz. Now 5G, you speak about more than 6 gigahertz, 28 gigahertz,
25, 28, it's going there
and
now.
73 gigahertz as well. So you are planning to radiate the electromagnetic waves at a very high frequencies, which was not done before.
I see. So the signal to noise ratio and the interference problem, does it get increasingly more problematic when you go to a shorter wavelength, like as you are doing now? Or
yes. So if you see that there is a relationship between the operating frequency and the wavelength and the distance, the path loss, which is called the way the signal quality degrades along the distance. Yeah. So if you are operating at a higher frequency, for example 4G, 2.6 gigahertz, your radio system can cover 100 meters, but in 5G it will cover only 10 to 20 meters. So distance of coverage, for example, you are at 30 meters away from an access point in 5G system, the signal quality is very low, but the noise or interference is dominating, then you cannot receive the same data rate what you can receive when you are just 10 meters away from the access point.
I see. So there's always the trade-off of the distance.
Yes. So you should make sure that you get a stronger signal quality compared to the noise floor or compared to the interference level.
I see.
Okay. I'm interested in the trend part of your work. I realize your core is communications, but I'm just wondering, in your mind, what are some significant things that we can expect to happen on the train side? It could be train comms or just trains in general, because I'm interested in trains, seeing that it's evolved from steam to what we have now in a span of 100 or so years. What do you think the future is looking like? Maglev?
Yeah.
Or
Well, if you see, in last 30 to 40 years, the advancement in the transportation is making everything automated. With less human interference, your transport system should operate. If you speak about trains, airways, roadways, or on sea. So use technology to reduce the human effort in transportation and maintaining the safety. So using the wireless technology, what they are doing is trying to deploy as many sensors as possible along the train tracks, on the train, and everywhere, so that they can use those sensors in reducing the human maintenance. Now, for example, there is a crack on the train track, or there is some issue. Earlier, people used to physically go along the train tracks, like investigate what is happening there, what is the quality of the train track, and look at is there any crack. Now, you have some sensors which are attached to the train wheels or near the train wheels, which can look into the train track along when they are moving. So this is called real time condition monitoring. You can look at the train track health, and you can look at the power quality, because these trains are electric. The quality of power, is there any tripping or any power failure? And you can look at the quality of the wireless communication system as well. For example, at one spot, if there is a higher wireless interference because of someone jamming the signals using their external Wi-Fi, you can know these locations. You either go there, mitigate the problem physically, or try to choose some other problem sitting at your office. The operator need not to rush to the train track or rush to the train to investigate what is happening, why the train stopped. Rather than he can use the automatic maintenance system or semi-automatic maintenance system, and he's more aware about the problem, reason for the train failure, or reason for any kind of trouble on the track.
is there, does Singapore in particular have a digital twin of the network that you can look at, and also the data you're talking about, that the trains at that point? Is there any other way to whether visualize, but like could be visualized, or just something that is on the computer that replicates what's in the world? Is that available?
Yeah, so in Singapore, they have started NTU SMRT COP Lab. There are multiple projects which are working on real-time condition monitoring, where you can simulate, or you have similar setup like what is there on the train track, like the power systems, or maybe some kind of tracks where you can attach the sensors and look their performance. So they're building this, and it's in progress. We can see it in near future.
I see. I have another question. So you're talking about the signals being lost sometimes because of interference and all those things. But whenever we're talking about signals that are passed using Wi-Fi, there's always the potential for someone hijacking and putting in their own information. What measures are currently there for the cybersecurity aspect of it? Because now someone can pretty much, if they're good enough, they can control the train and put in wrong information, and then we have an issue. That's not signal, like lost in the same sense, but it's still a signal problem.
Yeah. So this technology, whatever I've said, communication-based train control technology, it is in use from last 10 years, I could say. And these things, whatever you just said, happened in many other countries already, because they are using same Wi-Fi technology, and many other mobile users try to connect to these Wi-Fi system, and at a time they are like jamming or spoofing attacks. All these things happening. So what researchers are doing is we can do a spectrum monitoring study, which is nothing but knowing what kind of wireless signals are present in this environment. For example, there is a free software which is called Wireless Shark. You can install in your computer and look what are the different Wi-Fi systems or radio signals in the same frequency band or in your surroundings.
Okay.
Well, this is where you can know about the IP address and other details. But there is one more thing which we can do. We can do real-time spectrum monitoring. It means you install some kind of radio hardware on the trains where continuously the hardware with some algorithms detects the radio signals and detects the non-radio signals which are harming the CBT train signals. So a continuous analysis of these two signals, the train signal and the interfering signal, is carried out everywhere. So the operator, before there is a signal failure, he get to know that, oh, in these MRT regions there is a higher interference issue, or in these regions there is a lower issue, or there could be a jammer attack in these regions. So when there is a jamming attack, yeah, either you can switch the frequency of operation, or you can investigate which type of jamming attack is that. Is it a continuous radiation or a high power radiation?
It's intentional or
Intentional, unintentional, because these are unlicensed band. There is no license, so anyone can radiate the radio signals. So I worked on developing a algorithm which can detect the radio signals from the train, like the train signal, Wi-Fi signal, wireless CCTV signals. They use the same frequency band, and many other different signals using the same 2.4 gigahertz frequency band.
Are there ways for for someone to build an application that uses this data, or is this data sort of controlled within the operator's data sphere? Can people develop apps using the data that you guys collect using these systems?
Yeah, they can collect, but they cannot decode. So the interesting part of not decoding is every signal which you transfer is a coded signal. The person who has the similar code, he can only decode the signal. For example, when we are transmitting the wireless signal in the Wi-Fi setup, you have a code to represent, let's assume the data is transmitted in ones and zeros. Your original data is just one, but you are replacing that one with a code of length 1023 or 2046 or 409 something. So at least 1,000 times a larger number is replaced with the original data, and it is a coded information which only an authorized user has. You should have that key to decode every symbol 1010. Every symbol is carried with this code. You can only decode when you have the same code at the receiver.
So you mean it's another protocol above the Wi-Fi protocol, or?
No, this is called spread spectrum technology,
Okay.
which is either they spread the signal using the codes, or they use a frequency hopping technology where at time t1 you are transmitting at 2.41 gigahertz. At time t2 you're transmitting at 2.423, some other frequency. The gap between time t1 and t2 is 160 milliseconds to 300 milliseconds.
Oh, right. So thank you for talking to us about your research. Before we move on to something about your interests outside of research, is there anything you think is of interest that we might have not asked you about? Something that you find fascinating about your work, whether it's about comms, whether it's about trains, anything?
Maybe, are you speaking about the social life of a researcher?
No, we'll get to that, but I'm talking about in particular your research field.
Yeah.
Are there interesting things that you want the community out there or people to be aware of, like something you found during your research that, oh wow, that's really interesting, I didn't know that. Is there anything like that you'd like to share with the audience?
Yes. Well, usage of artificial intelligence in wireless comms. Well, I earlier said we need a signal identification algorithm to detect the train signals and non-train signals. So this can be done using machine learning tools or algorithms, which, to be in simplistic way, there are different algorithms. So using deep learning and machine learning, you can replicate the train signals, replicate non-train signals, and find out the better match between the detected signals and whatever the standard paths you have. So these things can be done if you have a lot of data or you generate data. So using AI in wireless comms, you can take it to the other level. What I mean, let's assume if you want to do a access point optimization for the entire 50-kilometer length train track. By using this approach of mathematical tools, whatever we have previously in last decade, so we can do a simplistic way using a evolutionary algorithm or anything, but using machine learning techniques where you introduce the optimization concepts, you can do it in a better way.
So machine learning can be involved somehow within these kinds of problems.
Yes, wherever there is data, you can bring machine learning tools there.
Right.
Yeah,
I think it's
for sure.
it's a Swiss knife. Okay. So let's move on to the other exciting stuff about your life, which is non-research stuff. Can you tell us what you do, what you've done, what you've discovered, and what you would recommend other people doing if they were doing research here at NTU?
Well, when I joined my PhD program in NTU, my perspective towards research was, the researchers should restrict their social life,
Okay.
more focus, spend 7 days a week in the lab, read a lot of papers, at least one research paper every day.
Sounds good.
But after 6 months, it's a burnout stage where I finished my semester exam, finished literature, finished simulation study. Then I felt like I'm exhausted. Then I realized that there should be some interesting part of the life other than your professional work profession. So then I slowly introduced hobbies like going for jogging with friends, dinners with friends, and then I was more attracted towards the student clubs in NTU. And in my second year, I contested the election and I was the president of graduate student club, NTU School of Triple E. Well, there I realized that, by being part of the student club, I can improve my skills like managing people, getting new ideas of how a researcher can get a new skill, presentation skill, find a right speaker, and make him teach other researchers how well you can present. Soft skills, writing skills, employment skills especially. Well, if you are a researcher in NTU or any other way, you have limited options. Either you can be a postdoc. Most of them, they go work as research fellow, which is like postdoctoral researcher. Well, but after joining the club and networking with a lot of people in the industry, being a club president, to invite them to give a seminar, then I realized that, okay, whatever work I'm doing, it has a wider application and industry people need me. Then I realized that, oh, yeah, I can still apply for the other companies as well, rather than just looking at the academic research fellow positions. So when I get an opportunity to know about these industry job openings, I try to share with other people as well. So I would say that, I was more narrow-minded when I joined PhD program, but luckily I was driven towards the student clubs and student activities where I got a chance to meet a lot of people in different areas, industries, and slowly my perspective towards my career changed.
So right now you think you stick with research or you move on to other things?
Well, I just want to do research.
Okay.
Research for entire life. So I got a
Entire
job.
life, huh?
Yeah, research in different things. Maybe if I'm bored with wireless comms, maybe I'll switch to the food processing industry, agriculture. But there should be research.
Okay, that's quite interesting. So I think that's really it for today. It was interesting to learn more about comms, about connecting trains and making sure that they're able to pass on the right information and not crash into each other. And it's nice to see that you have made some discoveries about how the coverage of tunnels affects signals. Actually, I think I have one last question, which is not directly related to comms, but the digging. How is it? Maybe it's not exactly that, but I'm interested in understanding the digging of tunnels. So is there a preference, like the ones that are curved and the ones that are straight? I suppose someone, if they could do a straight one, they would like to do that. So the fact that they have curved ones means there is an advantage to it. I'm wondering, is it just because people are like that, or the houses are like that right now, or was there any specific reason that the SMRT or whoever built this had these curved ones?
Well, when they are designing a train route, their goal is to pass as close as possible to more residential areas and make a lot of people to reach easily to the MRT trains and the tracks. So they design, the most important criteria is to go closer to the populated regions or the regions where most of the people can reach easily. So I don't think, I have limited knowledge in this civil engineering stuff, but I don't think they try to give more priority to make it straight. They want to reduce the distance.
Urban planning.
Yeah, urban planning, I would say.
Okay. Well, thank you, Shravan, and I think
Thank
your
you very
work
much.
definitely contributes to us being taken back and forth across Singapore in an easy way. So thank you for that.
Thank you very much.
Thank you for inviting me.
Thank you.
Right.
Yeah.
Thank you everyone for listening.
Right. And
Goodbye.
bye-bye.